Hi everyone, I'm Jacob Applegate. For my Capstone project, I worked with a team to create a postural support device for children in low-income families. Um, my team was me, Jack Campo, Kate Froling, Hannah Grebovich, and Mai-Ly Tran. And our faculty advisor for this project was Dr. Steven Skurlos. So a little bit of background into the project. These are some of our main stakeholders. I was part of Blue Lab Nicaragua prior to this capstone project, and they're a student organization at the University of Michigan, and they were the ones that we worked in parallel with throughout the project. Through that, we got contacts with FNE International and Salud para Todos los Niños, both organizations based out of Nicaragua, with some local contacts there. Specifically, two children named Allison and Monica, who both had cerebral palsy and were suffering with some serious seating issues due to their cerebral palsy. So just a little bit of background on cerebral palsy. It's a very vast like variety of disorders for one thing. So I mean, you could be as disabled as to not have function of pretty much any motor control, versus some children can still walk and run with cerebral palsy. So it is a very big spectrum as far as how it affects people. Allison and Monica were both higher levels of cerebral palsy, meaning that they do have a lot of like motor control issues, as well as seating issues and posture issues. So Monica is a 9-year-old child who is in level 3 and 4. Allison is a 14-year-old child. She lives with her grandmother and mother. While her mom's at work, her grandma is the main caretaker. And with all her seating issues, her grandma has a very hard time taking care of her. They get donated wheelchairs, so a lot of times it's not custom fit to them, and they don't have the money to get a custom fit wheelchair. So a lot of problems have been caused by this. For example, Allison has some severe scoliosis and dislocated her hip because of her cerebral palsy. And that's really when I came to Dr. Steven Skurlos back in October of 2020, kind of asking him if I could take this project and kind of run with it as a capstone, and then use it in the 450 class to work with the team and actually get a prototype done for Allison and Monica specifically. So here's a little bit of background just on the cost in general of these assistive devices. Typically for children in like America, the average cost is about $3,900 US for levels 4 and 5 of cerebral palsy. So extremely high, not something that is accessible to individuals in areas like Nicaragua and stuff like that. So that's kind of where we wanted to really lower the price and create something that wasn't as expensive. So a little bit of problem description. We made a basic problem statement saying that Allison and Monica are in need of low-cost, adjustable, and accessible seating device to provide them the proper support in order to prevent any further side effects from hindering their mobility and their health. Here's just the main focuses for us throughout the project. It was adjustable, accessible, and affordable. That was the goal. So we set up some requirements and specifications. We wanted it to be lightweight, less than 30 pounds, so that the grandmother could move this device and pick it up and be the caretaker. We wanted it to promote their skeletal alignment and have that 90-90-90 seating position, which is ideal for children with cerebral palsy based on our research. We also wanted it to be comfortable, low cost, and durable. Along with that, we needed it to be adjustable because they are two different individuals and they will grow, and we wanted it to kind of grow with them. And we wanted it to be stable. We don't want any accidents happening with the device. So then we went into some concept exploration and basically kind of started to move through this design stage. So we were kind of past our definition at this point and went into our ideation moving forward. And kind of here was our next checkpoint at our next design review. So some updates, we added a mobility function or a mobility requirement, and we kind of changed the adjustability requirement a little bit, added manufacturability and maintenance to our requirements because we got some stakeholder feedback saying that they wanted it to be locally sourced and waterproofed. because their children can have accidents, which could cause a lot of issues. So we wanted something, or we wanted it to be something that's waterproof. And also we didn't want it to require any more than 2 common tools to maintain. We did a bunch of benchmarking, looking into a bunch of different solutions adjacent and in the industry, basically to kind of get a good overview of what is out there, and what we can gather some inspiration from. From there, we went into kind of some concept generation using a morph chart. We used this just to kind of develop a bunch of functions and features that would allow us to kind of pick from each of these maybe, or kind of gather, again, more inspiration when we were going into our designing phase. So we brainstormed a bunch of different random ideas, crazy ideas, but it worked out because we ended up coming up with each one big idea, and we ended up deciding between each of our ideas from where to kind of go forward. So this was my concept, this was Kate's concept, this was Jack's concept, this was Hannah's concept, and this was Mai-Ly's concept. And I won't go too much into detail and into depth on them, but each of them kind of had different aspects of our morph chart. And we basically just kind of wanted to put together all of these ideas and kind of try and decide on which ones we were going to go with. To do so, we used a Pugh chart and kind of used mine as the baseline, and then went from there, finding that Kate's seemed to fit all the functions as best we wanted it to. So this was kind of our final design. We moved off of Kate's a little bit and kind of added to it. So this was our final concept for this specific design checkpoint. That said, moving forward, we did make quite a bit of changes to that design, because it wasn't the final iteration by any means, and we wanted to use the Pugh chart specifically to kind of see where Kate's could use some work. So we then gathered inspiration from the other ones and kind of moved forward and iterated upon her design. So another design review checkpoint, we started to look a lot into the adjustability methods that we could use. Some classic ones up here. The main one that we got inspiration from was the sail track. It was kind of a clever way to slide something up and down a track and kind of click it into place. It'd be very easy for anybody to use. So we ended up kind of using that as inspiration mostly. So going into the current solution at this point, we took feedback and kind of used Kate's design as a starting point. We looked at our Pugh chart and we kind of talked with our contacts with F&E and Blue Lab, as well as some of the people in the 450 class to kind of further develop and go into a kind of final CAD at this point. So we pruned and were able to get that. This was our final CAD solution. We were able to have these adjustability methods on the side that were using this O-ring track to basically slide the lateral supports for the child up and down, and these lateral supports would hold them in place and keep the posture right, while maintaining quite a bit of adjustability so that the caretaker could really customize it to the child, which was perfect. This was our initial idea for a aluminum base, water jetted frame, half-inch square tube stock, etc. And the idea was that it could actually fold up into itself, which would be perfect. And then here was the current solution, the rendering. And we did some engineering analysis to prove that this device wouldn't end up breaking at all, which again, that's part of our stability, and we would want it to be safe for the children. So we validated quite a bit of our requirements and specifications. And then moving forward, it was just a matter of prototyping and going into kind of that aspect of validation. We did some risk assessment and found that like the main areas of potential risk were kind of the clips, the sharp edges, and support breakage. These were all very unlikely to happen. Professor Skirlos just thought it was important for us to kind of state the main risks and then go from there and maybe iterate on them if needed. And we actually did. We decided to go with a plastic instead of an aluminum. It made it lighter weight, it made it safer, and it was very easy to use and to mold to what we wanted. So we used HDPE, which is a pretty solid piece of plastic, and it's very easy to water jet. or not water jet, but laser cut is what we ended up doing. And we got all the slits perfect for the Velcro straps to go in, so it ended up working out a lot better with the HDPE. So this was our budget at that point. We ended up having too high of a budget, and this is again where the HDPE kind of helped out. The aluminum ended up costing a lot, so we decided to kind of iterate on that towards our final design, which included HDPE instead. And a lot of like 3D printed parts. This lowered the cost like very substantially. So the backing here is made out of HDPE. These would be foam inserts on the side. The adjustability method is the same on all surfaces because we wanted it to be something that, you know, it was one method of adjustability basically. So we used these O-ring tracks and we custom printed out this 3D like basically puzzle piece to fit around the O-ring and also the little clip here. So basically you press down, you lift and you slide, and that's how you adjust it, and it could adjust up and down, side to side. So yeah, it worked very well. So then from there, the next step was to assemble, analyze, and assess. And I had to pause to get the prototype, but this has ended up the final design. So I will back up so you can see. But this is the device, folded all the way up. Here's it folded out. We have slits cut in the bottom for the nylon straps to go through and attach to any chair. These are the adjustability methods on the side. Now we don't have any of the padding on here yet, but the padding kind of will go on after, and it's something that we were going to add once we make sure that this design is the one that we want to go with. But basically, the way it works is these O-ring tracks are able to adjust this plastic 3D printed part up and down, and then same with the back headrest. And you basically just kind of set it in the chair, strap it around. It works extremely well. We've actually tested it on quite a few different chairs, and it fits to pretty much every chair, which is what we wanted. And the final price ended up coming out to only $167. So it's well under our budget. It's well in the range of what we wanted the price to be. And it's something that we're excited to kind of keep iterating on as this goes on. But for the Capstone project, I'm very happy with the progress. I'm very happy with where it's ended up at the end of the semester. So yeah, thank you for watching. Have a good day.